right. Hello, everybody. Today I'm going to talk about 3 different ways of how we can use NgRx Signals package to manage the state of an Angular application. But let's first talk about state management in general. So we can think of state management as a process of handling application data over time, including how data is stored, updated, and propagated to the UI. And usually in front-end applications, in single-page applications, we have at least 3 layers. We have a view layer, which is made of components. There is also a state layer, where we manage our state and handle side effects. And sometimes it might happen that state layer is integrated inside of the view layer. Today we are going to see this example, but we are also going to see use cases where state layer is separated, and we will also do a comparison between these approaches. And the third layer that we usually have is a data source layer, which is used to obtain data from the API and send requests to apply mutations. So UI is derived from state, actually. Every visual element is just a reflection of underlying state. State acts as a glue between data source and the view layer. And in most of the cases, state management layer is actually the primary source of complexity in our applications. And because of that, it's very important to have a well-designed state management layer as a foundation of maintainable architecture. Before we continue, let me briefly introduce myself. My name is Marko Stanimirović. I come from Belgrade, from Serbia. I currently work as a technical lead at a company called BlinkOps by day, and then by night I'm maintaining NgRx. I'm a creator of NgRx Signals and Google Developer Expert in Angular. So this is our agenda for today. Talk title says we have 3 dimensions, but I will actually show you 4 different options how we can use NgRx Signals package to manage the state. We can use SignalState in a component, SignalState in a service as an alternative to a service with a subject approach. Then we will see how we can use SignalStore, and last but not least, we will see how SignalStore can be combined with a recently introduced Events Plugin. This is our demo application for today. So we have a home page. There is a customers page where we are displaying a list of customers. We have an option to search them, to refetch them from the API, and to create a new customer. Let's first see how we can use a signal state in a component. So we have a customers component when we want to display a list of customers. First, we need to inject the dependencies, right? So in this case, because our state layer will be integrated inside of the view layer, we will inject our data access layer, or customer service in this case, directly into a component. Then we can define our state container by using SignalState, and SignalState accepts the initial state as an input argument. It can be used, so the state property can be used as a regular read-only signal, but what it also provides is it generates deeply nested signals for each state slice out of the box. So we can use those nested signals to create computed state. And then we can also define some side effects and state updaters. A template looks pretty straightforward. We just need to bind our state slices and call methods when events are emitted from presentational components. Now, from the architectural perspective, here we have a container component, we have presentational components, and inside of the container component, we are also doing a state management logic and performing side effects. When it comes to benefits of this approach, one of the benefits is definitely simplicity and minimal overhead, right? It's easy to implement and understand, and it's suitable for local state and small and self-contained components. On the other hand, we have a lack of logical separation. So collocating UI logic, state management, and side effects within the component reduces reusability and makes the code harder to maintain and scale as complexity grows. Let's now see how we can use SignalState in a service and introduce additional layer in our application, the state layer. So we would create a class, customer store. We can provide it at the root level if we want to manage the global state with this store. Then we are going to inject the dependency. We will define our state container. And you can notice here that now our state is private. We want to have a state encapsulation. We don't want to allow direct state modifications outside of the store itself. Then we can expose private members like queries, state slice, is pending state slice. We can also define computed state and updaters and side effects. Now our component looks like this. So we need to inject the store, right? And then just use its APIs. The good thing here is that when we properly apply a pattern with presentational and container components, we just need to update bindings in our container component. We don't have to touch the presentational components at all. Now, from the architectural perspective, we introduced additional layer that is now dedicated to state management and for handling side effects. So as a benefit, we definitely have better separation of concerns, right? It's also a benefit of using SignalState in a service is also we have a familiar store pattern. So it's well suited, for example, for teams that are transitioning from component store. It offers really minimal conceptual shift. But the disadvantage of using SignalState in a service that SignalStore solves is limited extensibility. So it does not support built-in or custom plugins out of the box, and as a result, we can have repeated logic across multiple stores. So to have actually the ability to create custom plugins and to reuse the existing ones, we can use SignalStore. To create a Signal store, we are using a function with the same name. Then as a first argument, we can provide a configuration. In this case, I want to provide my store at the root level. And then as REST arguments, we can provide a sequence of Signal store features. So we can use some base features such as with state to add state slices to our store. We can use with computed to add derived state. And as you can see here, inside of the with computed, we can access our state slices as signals. So SignalStore will actually do the same thing as SignalState. Under the hood, it will create deeply nested signals for us. Then we can use with methods to add updaters and side effects. And the good thing is that all these feature factories are executed inside of the injection context, so we can inject our dependency there as well. But when we define our store like this, there is not really a big benefit compared to the SignalState in a service, except a bit better organization of our code, right? Where the benefits of SignalStore really come is creating custom features and using the built-in ones. So for example, we can create a feature for managing the request status. Every store that performs some API calls needs a request status. We can do this by using SignalStore feature function that has very similar signature to SignalStore itself. By the way, SignalStore feature is inspired by RxJS pipe. So RxJS pipe function, it takes multiple RxJS operators and merges them into a single one. You maybe used it if you build custom RxJS operators. And SignalStore works in a very similar way. It takes a sequence of multiple SignalStore features and merges them into a single feature. So now we can use with request status feature inside of our store. In a similar way, we can also create other custom features. For example, we always want to display a toast or snack bar when our request status reaches the error state. Or we want to create a custom feature for local storage synchronization. Then we can also take advantage of using some built-in plugins, such as Entity plugin, that provides this with entities features, as well as updaters for performing CRUD operations. So we don't need to write this logic by our own. When it comes to usage inside of the customer's component, I don't have to change any single line of code. So everything remains the same. I can inject the customer store as any other service and use it inside of a component. Now, from architectural perspective, nothing changed, right? We still have our view layer with container and presentational components. We have a store layer and data access layer. But when it comes to benefits, Extensibility is definitely one of them. So it supports defining custom features and using built-in plugins, which reduces repetitive code and enables consistent and reusable patterns. We also have unified API design. So it offers self-descriptive APIs for well-structured state management logic. But the potential problem with, let's call it, vanilla SignalStore approach is that it does not offer mechanisms for inter-store communication out of the box. So coordinating logic across multiple stores requires direct dependencies, which can lead to tightly coupled code and reduced flexibility in large systems. So for that, we can actually use a recently introduced Events plugin. The Events plugin it's inspired by original Flux architecture. So here you can see the diagram of application flow with Events plugin. When something happens in our system, we are dispatching the event to the globally provided service called dispatcher that acts as event bus. Then, dispatched event can be handled by one or multiple stores. We are writing reducers for state transitions, effects for performing usually asynchronous side effects. Updating our state, the new version of state is reflected in the view. Then when something happens in the view, the new event is dispatched to the dispatcher, so this flow repeats over and over in our application. Let's now see how it looks, how the implementation looks with the Events plugin. So to create events, we can use function with name event group. It accepts a config object with two required properties. First required property is a source, so this is the origin of our event group. For customers page events, it will be customers page. And then, as a second property, we have to specify a dictionary of event definitions, where each event definition is a key value pair of event name and event payload. We can do the same for customers API events. And then, when we define our events, it's time to use them. We have to dispatch them from somewhere. So inside of the customers component, we can use this inject dispatch helper that accepts the event group as an input argument and returns a dictionary of self-dispatching events that can be then used inside of the component class, or we can use them directly from a template to dispatch events. Yes, so this is how the SignalStore implementation would look like by using the Events plugin. State definition of computed, everything remained the same. We can still use entities plugin, but then when it comes to state transition and handling side effects, we will do a bit different thing. We are going to separate them. We will handle state transitions by using with reducer function that accepts a sequence of case reducers. So inside of a case reducer, we define events that we want to listen to, and then as a last argument, we are providing a reducer handler function. The good thing is that we also have the ability to reuse previously defined custom updaters inside of the with reducer. Then for handling side effects, we are going to use with effects feature. We will inject the event service, listen to the dispatched events, and perform side effects. With effects is fully inspired by the NgRx effects package for the global NgRx store, if you're familiar with it. Which means that every event that we return here, as a result of our effect, will be automatically redispatched to the dispatcher. And when I use the Events plugin like this, there is really not a big benefit compared to using a vanilla SignalStore approach, right? Where benefits of Events plugin really are obvious is when it comes to inter-store coordination in our application. So let's imagine the following situation. We have customer model, and then we enter some details. We want to create a new customer. Without Events plugin, when save is clicked, we are going to call a method from a customer model store that will call the save customer from the customer service. On success, we will receive the saved customer, and then we have to inject the globally provided customer store inside of the customer model store and explicitly call add customer method. So here we have this tight coupling between customer model store and customer's global store. On the other hand, with the Events plugin, the first part remained the same. When save is clicked, we are calling a method from a customer model store. We are saving customer, and then on successful response, instead of injecting the global store and calling its methods explicitly, we are going to dispatch the event to the event bus, which is dispatcher in our case, that customer is saved successfully. Then in a customer global store, we can listen to this event and we can add customer to the collection. So this way we don't have direct dependency between these two stores. Let's see this in action. So here, this is the current version of the customer model store. What we are doing here, we are injecting the customer store, and then on successful creation, we have to call customer store.addCustomer here. So what we can do, first we need to define our events. And here I already created two events, created success and created failure. So now if I go back to the customer model store, here I can say dispatch is equal to inject dispatch, and I can provide customers API events, event group, as an input argument. Then here, on success, I can say dispatch dot created success, and I will provide the customer as a payload. In case of error, I will say dispatch dot created failure, and I will provide error.message. So now I can comment out this line. I don't need it anymore. I also don't need these two things. Now I will go to the customer store. So let me just navigate there. And then instead of having add customer method, I can create another case reducer here. So I can say on customers API events dot created success. I will take a payload, which will be a new customer, and then I can call add entity custom updater provided by the entities plugin to add customer to my collection. Now I don't need this method anymore, so I can remove it. I can go back to the customer model store, and I can also get rid of the direct dependency to the customer store. One last thing is to handle a request status when those two events are dispatched. And this is another good benefit that Events plugin provides. Namely, we can also manage our local state by using the Events plugin. This was not available before with global NgRx Store. Another good thing here is that we can partially integrate Events plugin only where it makes sense. So for example, in a customer store, I fully use the Events plugin. Everything is handled, like state transitions are handled by using reducer, side effects are handled by using effects, but then in a customer model store, I still have my methods. I still handle, for example, my dialog close by using methods as well, but then I injected dispatch here and dispatched some events to inform other stores that something happened, and I avoided direct coupling between them. All right, so now from the architectural perspective, we have another component in our system. In addition to view layer, store layer, and data access layer, we also now have events. So you can also notice that there is no two-way direction between the container component and store anymore. Container components still use a store, but only to read the data. If we want to perform some action, we're going to dispatch event to the event bus that will inform store, and store will apply state transitions, side effects, or both. So as a benefit, we definitely have decoupled architecture. It reduces tight coupling between stores and separates state transitions from side effects, improving code clarity and data flow predictability. Another benefit that I already mentioned is partial and incremental integration. So events can be really adopted gradually in specific modules or flow without requiring a full rewrite of the existing state logic. Events plugin can be also very useful if you want to migrate from global NgRx Store to the SignalStore, right? Potential disadvantages: increased architectural overhead. So introducing an event layer adds abstraction, it introduces this layer of indirection, which may be unnecessary for simple features and applications. So to summarize, one approach definitely does not fit all the use cases. Angular applications range from lightweight UIs to complex enterprise systems. And a modern state management solution, such as NgRx Signals, must scale and adapt accordingly. Team experience is also very important. So different teams have different levels of expertise with state management libraries. And with NgRx Signals, we really tried to provide solutions that are really easy for scaling. Also, balancing simplicity and scalability is very important, so choosing the right state management pattern early helps to avoid over-engineering while keeping architecture predictable and maintainable. And last year at NGConf, I was very excited to announce that NgRx Signals package reached 20K weekly downloads. Today, I'm happy to share with you that it crossed 330K weekly downloads. And this won't be possible, of course, without all of you, without our amazing community, and also without our NgRx core team. And almost 2 years ago, one person started contributing to the NgRx repository more actively. Then we invited him to join us as a collaborator. He provided some brilliant ideas. He also had a great contribution when it comes to content creation. And a few weeks ago, we decided that he will join the core team. So I'm happy to share with you also that Rainer Hannekam joined the NgRx core team. All right, the source code of today's demo application is available. You can scan this QR code, or you can go to my GitHub profile and you will find it there. It has the same name as the name of my talk. With that, thank you very much for your time. Enjoy the rest of the conference.